Hello everyone, so today we're going to see how to study a function. In this case, I've chosen this example, and I also chose all the important parts that you have to understand about a function in order to properly study it. So first you have to determine the domain of the function, then calculate the limits of the function and its asymptotes, then calculate the first derivative, determine what the extremes are, like minimum or maximums, and then calculate the second derivative and determine its inflection points. And at that point, you will be able to draw that graph. Even though this function might look a little bit scary, at the end of this video, we will be able to draw it. Okay, so that's the point of a function study. So let's start with the domain of this function. So what is the domain of f? Domain of f is every value that this function, that x can take for this function to make any sense. Okay, so the only values that are not in the domain of this function are values for which the function simply wouldn't work. And so in this case, the only value for which this function would not work would be if the exponential of x plus 1 were 0, because you cannot divide by 0, right? But luckily for us, an exponential can never be equal to 0. Never. Okay, even if the exponential is exponential 0, it will always be 1. So this exponential can never be 0, and as such, every value is accepted, and the domain of this function is R, which encompasses basically all the numbers, all the values. R is the same as minus infinity to plus infinity. Okay, that's the domain of this function. Okay. This was a very easy part, but a very important part. Now, let's calculate the limits of this function and its asymptotes. So we want to know what this function does at these 2 points, at these 2 limits. So first, let's calculate 6 plus 5x plus x squared divided by exponential x plus 1. Okay, what is the value of the limit of this function when x equals to plus infinity? So if we use x equals to plus infinity on this part, this will be plus infinity. An exponential of infinity is also infinity. So we have a form infinity divided by infinity. When we have this form, there is a theorem we can apply that is called Hospital theorem. Maybe I will make a video on it to explain it to you, but it's really simple. Basically, when you have this form infinity divided by infinity, you can once again derive the function. So let's now derive this function. 6 disappears because there's no x. 5x equals to 5, and x squared equals to plus 2x. And the derivative of an exponential is always the exponential. So in this case, exponential of x plus 1, this remains unchanged. Now we look once again. If we apply x equals to plus infinity, we have once again plus infinity, and here plus infinity. So we have once again this form infinity divided by infinity, and we can once again do Hospital theorem. And now we remain with 2 and exponential x plus 1. 2 obviously being equal to 2, and exponential infinity being equal to infinity. When there's a number like 2 divided by infinity, it will always be equal to 0. Okay? What does that mean? We have an horizontal asymptote with value y equals to 0. We will later on see how this applies when we will draw the graph, and I will explain a little bit better about what this asymptote and this y equals to 0 really mean. Okay, this is the limit when x equals to plus infinity. Now we have to do the same, but obviously with x equals to minus infinity. Now you might think that it's going to be just the same result, but it's not. Because if we apply here minus infinity, this will to be plus infinity, because we have minus infinity squared, which is obviously equal to plus infinity. But the difference is here. Exponential of minus infinity will be equal to 0. Okay? And infinity divided by 0 is infinity. So we found out that the limit of an infinity equals to infinity. When that happens, we use Cauchy's formula, which is also another formula I might explain in another video, but it's not really important to go into the intricacies of this formula. Now we just do the exact same, but this time we divide this function by x. So we have 6 plus 5x plus x squared over exponential to x plus 1, all of that divided by x. If we just calculate this, we get 6 divided by x plus 5 plus x divided by exponential of x plus 1. So what I did here is just I divided 6 by x, 5 by x, which 5x divided by x equals 5, and x squared divided by x equals x. Okay, so now what we have to do is, once again, we have to calculate. What does that mean? If we have 6 divided by minus infinity, this equals to 0. 5 obviously equals to 5, and x equals to minus infinity. So all of this will be minus infinity, and this will be 0. So we have once again minus infinity divided by 0 equals to, well, no secret there, minus infinity. So what we found out is that the limit when x goes to minus infinity is infinity. We are interested in this value. Okay, now this was the important part for the domain and the limits of this function and its asymptotes. Now in the next video, we will concentrate on the first and second derivatives, and in the third video, we will talk about the graph.